thought of the book as directed to philosophers. And I think not a lot of them read it. I think it was picked up much more widely than that and was no particular force for some time in philosophy, although the philosophers surely knew it. But I remember, I guess it was Peter Hempel's telling me that he had been to a meeting in, I think it was Israel, at which groups had gathered and said that book should be burned. And all this talk about irrationality. And irrationality in particular, irrationality and relativism. The thing that bothered me about the Chappelle review was all of the talk about relativism. I didn't think it was, I thought, I saw why he said that, but I thought if he thought a little bit more seriously about what relativism was and what I was saying, he would not have said anything like that. If it was relativism, it was of an interesting sort of relativism that needed to be thought out before the tag was applied. In practice, I would say it's not a relativistic book. And although I would have had trouble initially, I tried in the end of structure to say in what sense I thought progress was there. I largely squeezed it out, the answer to that. Talked about the accumulation of puzzles. And I think, I would now argue very strongly, that the Darwinian metaphor at the end of the book is right and should have been taken more seriously than it was, and nobody took it seriously. People passed it right by. It's a question of stopping to see us as getting closer to something, but see us instead as moving away from where we were. And that was, I was saying that was beyond anything I'd really quite grasped until the point at which I had to really wrestle with that problem and say something. But saying that was important to me, and it led to things that have happened since. And I think it might have been picked up and recognized more.
We are trapped inside a paradigm. We like to think that science is a process which is rational, perhaps even objective. We make hypotheses and then we test them. Then along came a man who disagreed.
The man was a triple threat: a physicist, a historian, and a philosopher of science. And he said, yes, it's great that we have all these strong ideas on how science should work. But when we actually look at the past, and we actually look at the evidence, we'll come to a very different conclusion. The man was Thomas Kuhn.
In his groundbreaking work, The Structure of Scientific Revolutions, he argued that the most scientific practices, or as he liked to call it, normal science, all operate within a paradigm. In this video, join us as we take a deep dive into this revolutionary book. We'll be focusing on chapters 4 and 10 of The Structure of Scientific Revolutions.
Chapter 4: Normal Science as Puzzle Solving. According to Kuhn, normal science is a highly determined activity, but it need not to be entirely determined by rules. Normal science ultimately leads only to the recognition of anomalies and crises.
Kuhn affirms that normal science is not interested in novelty, and that discoveries that might challenge the status quo are frequently disregarded or aggressively denied.
Kuhn then tries to comprehend why scientists are so devoted to conducting normal science. Like, a jigsaw puzzle is a satisfying way of completing a predetermined picture. Kuhn contends that normal science is an exciting way of proving what is already known. However, nobody will approach puzzle solving in the same manner twice.
Everyone has a distinct approach, and some people may go more quickly than others. Kuhn believes that scientists are more driven to demonstrate their ability to solve problems than they are to benefit the world.
For example, your instructor asks you to get a lengthwise paper, but you only have one whole sheet of paper, so your blackmate decided just to tear it into half, but it turned out not pretty good. So your other blackmate brought scissors to cut it into half. But instead of solving the problem got worse because the paper is no longer divided lengthwise.
In this chapter, Thomas Kuhn points out that there was a lack of novelty. He stated that the normal science is not focused on making groundbreaking discoveries or challenging the prevailing paradigm. Instead, it aims to make an incremental progress by refining and elaborating on existing knowledge. Scientists within a paradigm are typically not concerned with questioning the fundamental assumptions of the paradigm itself. Consequently, Kuhn acknowledges that normal science is not without its challenges, referring to the resistance of anomalies. Anomalies, which are unexplained observations that do not fit within the existing paradigm, may arise. However, he notes that normal science often resists the acceptance of anomalies and may attempt to explain them within the existing framework rather than considering the paradigm shift.
The philosopher of science, Thomas Kuhn, developed or published in 1962 a book on scientific revolutions, in which he said that you had a paradigm of theories that dominated a certain period, and then you had normal science for a long time following. Then again you had a major scientific revolution resulting in a new paradigm, which then dominated all the thinking for the next 20 or 30 or 50 years of normal science. Well, I went through the history of biology, where we also have many scientific revolutions. Just think of the Darwinian one in 1859, and I found that they do not at all go on like Kuhn says. For instance, let's take in the case of Kuhn, always a paradigm is totally replaced suddenly by a new paradigm. Well, Darwin in 1859, when he proposed the theory of natural selection, this was not at once accepted. In fact, it took 80 years before it became a majority view, but it competed for this whole period with three other explanatory theories of evolution, like inheritance of required characters, mutations, cosmic teleology, and so on and so forth. So I developed gradually ideas in this field that were quite different from the standard opinions of the historians of science, most of which had come out of physics. And I first published individual papers. For instance, I did one on Louis Agassiz, who was so opposed to Darwin's evolutionary theories after they came out in 1859. And I showed that Louis Agassiz was dominated by a set of concepts and ideas that simply made it impossible for him to accept Darwinian evolution.
Chapter 10: Revolutions as Changes of Worldview. Kuhn delves into the profound nature of scientific revolutions and their influence on how scientists perceive the world and conduct research.
After a scientific revolution, scientists are responding to a different world. Though the world does not change with a change of paradigm, the scientist afterward works in a different world.
What scientists see during their research depends on the normal science tradition in which they operate. Therefore, the world that scientists see after a scientific revolution seems incommensurable with the world they saw before the revolution.
Paradigm shifts are unlike Gestalt switches in the following respect. For Gestalt switches, there is an external standard with respect to which the switch can be demonstrated. However, for paradigm shifts, the scientist can have no recourse above or beyond what he sees with his eyes and instruments.
He introduces the concept of incommensurability, which means that when a new paradigm emerges, it often makes the old paradigm and its theories incomparable. Kuhn discusses the resistance within scientific communities towards adapting new paradigms, often due to the vested interests of established scientists in the old paradigm. He emphasizes the role of anomalies, which are unexplained observations that accumulate and create tension within a paradigm, in triggering scientific revolutions.
Kuhn's insights in this chapter underscores that scientific progress involves significant shifts in worldviews and conceptual frameworks, challenging the conventional notion of gradual scientific accumulation.
According to an alternative view, scientists do not see the world differently as a result of a scientific revolution, but rather, they simply interpret their observations differently. This view is a part of a philosophical paradigm.
Scientific revolutions cannot be reduced to mere interpretations of individual and stable data for the following reasons. First is that scientific data is not consistent. The move from data associated with an old paradigm to data associated with a new paradigm does not resemble interpretation.
Another reason is that a paradigm is generally assumed in interpretation. Data interpretation can articulate but do not correct a worldview. And flashes of intuition that frequently lead to a new paradigm are not logically or piecemeal linked to particular items of experience based on the old paradigm.
Like Priestley and Lavoisier, they both saw oxygen, but they interpreted their observations differently. Consequently, Aristotle and Galileo both saw the pendulum, but they also interpreted their observations differently.
In summary, chapters 4 and 10 offers complementary insights into the evolution of scientific knowledge. Chapter 4 introduced us into the concept of normal science, emphasizing the routine, puzzle-solving nature of scientific activities within established paradigms. Scientists in normal science work within a shared framework, aiming for incremental progress while often resisting anomalies that change the status quo. This chapter underscores the stability and continuity within scientific communities during periods of normal science. Chapter 10, on the other hand, delves into the disruptive force of scientific revolutions. Kuhn explains that these revolutions occur when anomalies accumulate, leading into crisis, in which the prevailing paradigm can no longer account for new observations. During revolutions, scientists undergo a fundamental shift in worldview, and the emergence of new paradigms fundamentally transform the scientific landscape. Kuhn introduces the idea of incommensurability, highlighting the difficulty in comparing paradigms and emphasizing that scientific progress involves profound changes in how we perceive the world. Together, these chapters reveal a dynamic tension in scientific development: the stability and progress of normal science, and the transformative upheaval of scientific revolutions. They emphasize that science is not a linear, cumulative process, but rather a complex interplay of continuity and disruption, challenging our understanding of how knowledge advances in the scientific realm. And so, as we journeyed through Thomas Kuhn's revolutionary insights in chapters 4 and 10 of The Structure of Scientific Revolutions, we've uncovered a world where science isn't just about cold, hard facts, but a dynamic interplay of paradigms, anomalies, and the ever-shifting lens through which we see and view the universe.
Kuhn's work challenges us to question our assumptions about the unyielding march of scientific progress and invites us to embrace the notions of revolutions. Those seismic shifts in our understanding are the engines of true innovation.
Just like those scientists who tore, cut, and contemplated the single sheet of paper in their pursuit of a solution, we too must be willing to tear away the comfort of established norms, cut through the tangles of tradition, and contemplate new paradigms to truly advance human knowledge.
As you embark on your own scientific journeys, remember Kuhn's words: the scientist can have no recourse above or beyond what he sees with his eyes and instruments. Embrace the anomalies, challenge the norms, and dare to see the world through a new lens, for therein lies the essence of scientific revolutions.
And with that, we conclude our exploration of Thomas Kuhn's paradigm-shifting ideas. Keep questioning, keep exploring, and who knows, maybe you'll be the next one to spark the next scientific revolution.